Hey Valley Kids, here is the part 2 of the Unit 2 review on Schoology, the answers. Following numbers represents the ages of people on a bus: 3, 6, 27, 13, 6, 8, 12, 20, 5, 10, 10. Calculate the mean of their ages. This one here, we're just going to take and add them all up. You're going to get 110. You divide it by the number of ages there are. There's 10 people, and it turns out to be 11 years old. Question number 2. Mean, median, and mode. The following numbers represent the ages of Miss Palenka's sworn BFFs. The group is also known as Pinky's Pals. Find the median age of her BFFs. So we've got them all here. We've got to, if it's going to be median, you're going to have to put them in order from smallest to greatest. But she's got a lot of young friends, and everybody else is really old. Wait, there's a 38. Oh, that's her husband. I don't know. You can draw any conclusions you want there. If you line them up, 71 is the median age of her BFF. Pretty old. Not like me, a young guy. 11.4a, number 3. The following represent age distribution of students in an elementary class. Find the mode of these values. Just take a look through there and you will find that 9 is the mode. Got several of those. Next one. 11.3ab, create circle graphs. So study this information here. Vehicles at Fleet Farm and the frequency. Okay, if you were to make a circle graph for this information, what would be the measure of the central angle of the car portion? Well, you got to add all these up and figure out how many there are. So if you add them all up, you're going to find out that there are a total of 96. And there's 36 cars. So 36 out of 20 or out of 96 is going to be proportional to something out of 360. Multiply diagonally and then divide, you'll get 135 degrees. So out of a 360 degree circle, that would be a 135 degree angle. All right, continuing with the circle graphs, study this data. The top 5 advertisers spent a total of $559 million in advertisements. The nearest whole degree, what will be the central measure of the PepsiCo sector? All right, the PepsiCo sector here. So I would add all of these up. I would take and subtract that number from 559 million. And I found out that there was 180 million must be the PepsiCo's share. So 180 million out of the 559 million is equivalent to some measure out of 360. So multiply diagonally and then divide. We came up with 115. And then when you round that to the nearest whole degree, you get 116 degrees. Finally, the Little Debbie one. I'm going to make this just a touch smaller so it fits just a little bit better. Little Debbie's, what percentage of the Little Debbie snack cakes come from Swiss cake rolls? Round your answers to the nearest 10. So on this one, let's go back to the big one. I would just take and add all of these percentages up all the way around. And if you do that, I believe you're going to get 79%. So if you take 100% and subtract that 79%, you'll find that the Swiss cake rolls, which is by far the best, would be 21%. The Nutty Bars are good. I can't believe they scored that well, though, compared to the Swiss cake rolls. All right, the next question. Circle graphs here. Finding the central angle. This is probably the most complicated question in terms of solving it. So these are measures of central tendency for the Olympic speed skating. And so we've got all the data listed here, the times from 1928 to 1988. And they are not listed in order from greatest to smallest. They're listed by year. So you'll notice there's some of the slowest times were here, some of the fastest times were here, and in the middle it's kind of mixed up. Total of 14 scores. I've given you the mean, I've given you the mode, and I've given you the median. Now, if we add this additional score right here of 39.44 is the 15th, what is going to happen? Well, it's below the mean, so we know that the mean is going to go down. The mean is going to move. Let's just check and see if there's 39.44. Well, here's 139.44. But the mode of 43.4, there are three of those, so it's not going to change the mode. We have two of them, but like I said, it won't change the mode. The median, it's going to shift the median. We know it's going to shift, but we just got to see if it's going to change it. So what I did was I took and laid out all the median scores here. I know there's going to be 15, so that I know that the 8th one will be the median for the new set of data, and it'll be between the 7th and 8th one for the old set of data. So what I did was I took and put the first 8 members of the data set in numerically from the slowest time down to the fastest time. So here's 43.4, 43.4. I listed them out. So this is the first, the second, the third, the fourth, the fifth, the sixth, the seventh. So for the original data set, the median would be right here at 40.2. Because it's between 40.2 and 40.2, it doesn't change. So when we add the extra term, the 15th term, it'll now shift over to become the 8th one. That way we have 8 on one side, 7 on one side of the median, 7 on the other side, and then the median in the middle. And so when it shifts over from the middle of these to this one here, it's still going to be 40.2. The median doesn't change. The only answer here that changes here is F, the mean. Okay, let's see. Answer A, B, C, or D here, the complete histograms. The correct answer here is which one shows the prices for 10 different magazines. So here are the magazines. Which histogram shows it? Number A shows the correct answer. Here we go, another histogram. This table shows cars in a parking lot at 6 p.m. each day for 2 weeks. So we've got the histograms, and when you examine them, C is the big winner. Okie dokie. Let's see. Okie dokie. Survey asked 310 people how far they drive to work. Here's the histogram and the results. Which of the bars stands out? Tell what it might tell you about the drives. Well, this one stands out. It's by far the largest, and it's also got this gap here. It really does stand out. And what it tells me is that the number of people who work here, or there's like, looks like 70, 60, 70, 75 people. I haven't got my glasses on, but it looks like 75 people have a very short drive to work, which is letter D. The next one. I opened up this bag of M&Ms and sorted the candies by color. I started eating them candies one by one. What are the chances of randomly choosing 2 yellows? Well, the first time we go in, there would be 5 yellows out of a total of 30 candies. We add these up, that's 30. The second time, there would be 4 candies, 4 yellows, because I probably ate a yellow, and there would only be 29 M&Ms left, because once again, I ate one. So after that, we can reduce 5 30ths down to 1/6 times 4 29ths. And then we can cross-reduce the 6 and the 4. We can get that down to 1/3 times 2 29ths, which multiplies out to be 2 87ths. Number 12. Using the same data, if I purchased a jumbo bag of M&Ms containing 288 candies, how many green candies can I expect to get? Well, if you take the 6, and it's 6 out of 30 are green, so if you take 6 divided by 30, you're going to get 0.2. And just take 0.2, or 20%, times 288. It's 57.6, which you round to the whole nearest candy would be 58 candies we can predict using sampling. You could box this up too. You can do this as 6 out of 30 is equal to how many out of 288. I just flipped it to a decimal. It was really easy. Here we go again. At Cookie 30 last Monday, 24 students were present. 3 of those students chose cheese and crackers over Oreos. Based upon the sample, predict how many cheese and cracker packs I need to buy for April. You can assume that there will be 528 treats given out during the month. Well, again, you could box this up. You could go 3 out of 24 is like how many out of 128? I just took 3 divided by 24. That's 0.125 or 1/8. I multiplied 1/8 times 528. Be 66 kids would. I'd probably need 66 cheese and cracker Oreos. Again, this is using sampling to predict outcomes. Hope you got them all right. Hope that helps you understand them. Have a great evening. Thanks for listening.